Hello friends, good afternoon. Myself Dr. M.H. Annaya and friends, in today's session we are going to work out a problem on the section of a square prism. So here the question for today's session reads like this: a square prism of height 70 resting on one of its square faces on HP is cut by a section plane which is normal to VP and inclined to HP in such a way that the true shape is a rhombus with the diagonals measuring 40 and 60 Friends, so it is a question on the section of a square prism. It has some side and it has the height. Height is going to be 70 and he has not mentioned anything about the side of the square. Friends, remember, when the prism is held with one of the rectangular surface parallel to wall or one of the shorter edge perpendicular to VP, you will get the true shape as a rectangle. We have worked out already a problem on this. But here, friends, he has not given the side of the square prism. He has given only the height. And remember, friends, when you hold this prism with one of the diagonals perpendicular to VP, just like this, perpendicular to VP, or all the four sides equally inclined to VP, this diagonal of the prism is seen in its true form in the front top view and also in the true shape. So whatever the dimension you have got here is the dimension which is shown here as 40 This will be 40, and when it is cut at an angle, so he has specified the true shape should become a rhombus. So friends, we are going to hold this prism with all the four sides equally inclined to VP and get the top view a square and front view two rectangles. You are going to get like this. Friends, let me commence the problem by drawing the top view of the square prism. Here, the diagonal which is perpendicular to the VP, that is this diagonal which I am going to mark here now, A, B, C, D. This diagonal BD should measure this 40 So we can draw two lines at 90 degrees to each other and mark on that 40 by 40. AC is equal to BD is equal to 40 each, and obtain the corresponding front view. So friends, front view is going to be a rectangle, and we will have this line here. So all these lines are obtained by projecting from the top view. So just an arrow like this, that means we have to construct this figure and obtain this. And according to this is going to be 40, or I can show this side also. Any one side, we can show this dimension BD is equal to 40 millimeter, and we have named this as A, B, C, D. And here corresponding to this, the top face is A dash, B dash, D dash and C dash. Bottom face will have A1 dash, B1 dash, D1 dash, C1 dash. This is O comma O1. O is the center of the top face, that is O dash, and this is O1 dash. Remember, whenever any prism is placed on HP or anything including a cylinder, cone, whatever it may be, the line or the axis O dash O1 dash will be perpendicular to HP. Friends, you got the front view and top view. And now he says it is cut by a section plane such that the true shape is going to be a rhombus of 40 by 60. Friends, to get the rhombus, the section plane here should be necessarily be an inclined section plane which is perpendicular to VP. So friends, when it is cutting all the four vertical edges at an angle, so the lines on this BD will have a dimension 40 mm in the true shape, and the other one will going to be 60. So how to obtain this, friends? So first of all, diagonal measuring so and so, I will draw the midpoint of that axis, and if I draw a section plane at an angle theta such that the maximum diameter of that or the diagonal will measure 60 mm. So friends, what I do, I take the midpoint as center and strike two arcs on both the sides. That is an arc here to cut C dash and also another arc to cut A dash here. And I will extend this and say this is the section plane SS. And this section plane is making an angle of theta with the horizontal. This theta can be measured. That is a part of the question. Measure the locate the position of section plane. So the section plane SS is perpendicular to VP and inclined at theta. This can be measured. I will say measure the inclination of the section plane. Friends, after getting this, you will have to remove the portion above that, throw away and darken the remaining portion of the solid. So we are going to have like this. This is going to be the front view along with the section plane. I will say FV. So this part we have got. Then comes the sectional top view. Means in the top view you should be able to get how the section is seen. Friends, if you observe the front view of the figure, the longer edge AA is cut here and that is going to appear here. So we can call this as point number 1. Similarly, BB and DD are cut at this point. So BB, you can call double marking here. This is AA, this is CC or CC1, AA1, this is DD1. Say. So here, this BB and DD are cut here. So BB point is this and this DD is here. So we got 3 points. Finally, the vertical line CC is cut here. This is going to be point 3. Friends, we have got 4 points. That is the 4 corners corresponding to the point where the section plane is cutting the vertical edges. Sorry. Friends, you have named them 1, 2, 3 and 4. Let us see how they appear here. This is point 1. This is 2, comma 4. Let mark here 2, comma 4. And this is going to be point 3. And remember friends, this gap whatever we have got is 30 mm. Same as this, that is 30 mm. That is in the true shape, the value of this major dia should become 60 as per the problem. Friends, here we got all the 4 points. You will join them and we will hatch that. Show the section part in the top view. So this view will give you STV. STV stands for sectional top view. Then comes friends SEV. So what is SEV? That is the sectional side view of this. How to obtain that? Friends, as I told before, this portion above SS is removed. We are left with only this portion. And if you view from this side, whatever the view you get on the right profile plane After removing the upper part P, after throwing away this, will give you the sectional end view, that is right sectional end view. Okay. Now friend, right sectional end view, let's see how to apply. Sorry, it is left sectional end view. Now friends, to get the sectional end view, we will write a line vertical, call it as x1 y1, a vertical line, and here this is at an angle of 90 degree. We will assume that the solid is not cut by any section plane, and let us obtain the corresponding end view of this prism. So we can extend a line from here friends, a 45-degree line to be drawn here, and we will transfer all these points to that. So this is one point, this is the second middle point. So friends, we have got one line here, one here, and one here. So this is the left end view without the section plane. Let us name it now as this is D. D double dash is this one. The last one is B double dash. Center is A double dash, C double dash. And this is O double dash. Bottom is O1 double dash. So friends, we have got all these naming for done for the top facing. The bottom is D1 double dash. This is A1 double dash, C1 double dash. This is B1 double dash. So friends, you got these 4 points, 1, 2, 3, 4. We will transfer all these onto this figure. So 1 is an AA. I write a horizontal from 1, 1 till AA. This is point 1. Then 2 and 4. 2 is on BB. A line from here. BB is here. Second point you have got. And BB is over. DD is 4. This point is going to be 4. Then you have got here on this the point 3. At equal distance you get point 3. So you have got point 3. So we got all the 4 points. 1, this is 2, this is 3, and this is 4. So join all these by straight lines. 3 to 4, 4 to 1, 2 to 1, 3 to 2. Friends, after obtaining this, you show this section. So hatch it or section it. So after sectioning, the portion below that section is retained. So I am going to show this by dark lines. This also by dark line. Friends, here the portion or the lines above that section should be shown by thin line. Means this is thin line, thin line, thin line, and this is thin line. Friends, this figure is the left end view with this section, and we will call this as left sectional end view or sectional end view as seen from the left. Friends, if you practically see, this is how it will look. So it was like this, it was cut at an angle, and this is how it is seen. So you will be able to see the lines below that section. This hash section is the black portion I have shown here, and this is how we obtain the left sectional end view of the solid. So friends, this is over, and he is asking us to show the true shape of section. Okay, how to show the true shape of this section? We know very well it has to be a rhombus to the given dimension. So 40 by 60. Friends, what we do, we write a line parallel to SS anywhere outside this figure. So this is the line I have drawn. Some line, this line is parallel to this section plane and at any convenient distance. And from all these points, 1, 2, 3, and 4, we are going to write perpendiculars. So this is one line, this is second line, this is a third line. So we have got all these lines drawn. Remember, the lines so drawn are all normal to this. These are all perpendicular lines. So here above this line, we have to mark the points 1, 2, 3 and 4. Friends, start from the point 1. Point 1 should be marked on this. This is this much distance from xy. So I will mark that point as 1 here. Then 4 is very closer to this at this gap here. So this is going to be 4. And next is 2 on the same line at equal distance. So this is going to be 2. Here 3. Distance of 3 and that of 1 are the same. So you are going to get point 3. This is point number 4. So friends, we will join all these by straight lines. So I will join 1 to 4, 4 to 3, 2 to 3 and 2 to 1. Friends, this figure 1, 2, 3, 4 so obtained is the true shape of section, and this true shape of section is rhombus. That's already specified in the question. So this is a rhombus, and friends, this rhombus will have the dimension. So this value from 4 to 2. 4 to 2 is nothing but that is 40. So we are going to have this as 40 millimeter, and the dimension perpendicular to that or the longer side of this will have a dimension 60 mm, because this distance is same as this. So if you join that, 1 to 3 is 1 to 3. They are parallel and they are the same dimension, that is 60. 30 plus 30 is 60. Friends, this will give you the true shape of this section. Finally, friends, you have been asked to find out the dimension of the side of the prism. So they had not specified in the beginning. Now they are asking what should be this side. Friends, after construction of all these, if you just draw lines parallel to this, you can find out what is the distance. So this distance will give you the side, the measurement of the side of the square. So this you will have to measure. And friends, this will give you the complete solution for the square prism cut by a section plane, resulting in the true shape a rhombus. Friends, you are happy with the presentation? Do subscribe to my channel without fail and have a nice day.